Good morning. Thank you so much for that wonderful introduction. And thank you all for joining me today to talk about robotics and coding for young children, one of my favorite topics. So let me go ahead and get started. But first, I do want to say a big thank you to the Augustine Educational Foundation and Sacred Hearts Academy for putting on this wonderful event and making it a free resource and event for Hawaii's teachers. Thank you. So let me tell you a little bit about myself and my work as it relates to robotics and coding for young children. My name is Amanda, and I am an ed tech researcher and consultant. I say on all things ed tech, but actually it's mostly coding, computational thinking, robotics, and engineering type of materials for young children. I have my master's and PhD in child development from Tufts University, where I worked with the Dev Tech Research Group. That's the creator of one of the robotics kits that I will be sharing with you today. I do live in beautiful, sunny Oahu, not that sunny today, but my remote appointments can sometimes confuse people. I'm a lecturer remotely for Tufts for the Early Childhood Technology Graduate Certificate Program, which I'll tell you about again at the end of this presentation in case any of you are interested in more virtual learning and professional development opportunities along these topics. And I'm also associate faculty for the University of Phoenix's College of Doctoral Studies EdTech program. I'm an author, an educator, and most importantly, a mom of two young children myself. So I really do approach the curriculum and the choices of technologies and tools from both a professional perspective, but also things that I've been trying and using at home with my own kids. So if any of you are parents, that's definitely something we can chat about in the Q&A or after this presentation as well. So feel free to share in the chat. Caitlin will be moderating and we will have some time for Q&A at the end. And also just if you all want to connect with one another, and I will read through that chat at the end of this talk as well, what your role is in education and what brought you to this particular workshop, why you're interested in this. This is the plan of what we will attempt to squeeze into 45 minutes. We're going to talk about, before we get into the actual robots and coding that we can do with young children, we will talk about why it's important to start introducing robotics from an early age. Early childhood educators have so much on their plate already with literacy and math and other things. You know, why is robotics something that should also, in my opinion, be in there as well? I will introduce a few of my favorite robots. Today, I'm going to be showing all screen-free robotics because I think there is this idea that to teach coding at an early age, we need to give kids tablets and computers and screen time, but that's not true. There are a lot of totally 100% tangible hands-on kits that can be used as well. So I'll be showing you a few of my favorite ones that I have taught with, and including one kit that I worked on the development of, the Kibo Robotics Kit. I'll be sharing with you some unplugged games and resources that you can do even without a robotics kit in front of you, and sharing some final tips and letting you know where you can find more tutorials and more help after this presentation. So why robotics in early childhood? That first question that I presented. Well, there's a lot of reasons, and I will get into some of the things you see here, these cited research reasons of why robotics can be beneficial to young children. But in my opinion, robotics in early childhood, the answer is it's just a good time. This is when kids are asking these big why questions. They're trying to understand the world around them, and they have this unfiltered curiosity. And robotics offers a way to answer some of these questions. My son asks me, why does the water turn on automatically when I put my hand underneath it? And that's a sensor, right? It's a distance sensor. And we can use a robotics kit to show kids how that works. We can show them how sensors and outputs and lights work through this fun, hands-on kit, and help them answer some of the big questions they have about how the human-made world around them works. in early childhood, we are answering a lot of questions for them about the weather and their environment and the natural world around them. But the truth is that kids today are growing up in a very human engineered and technological world as well. So if we want to help them answer their questions and things that they're curious about, robotics and these tools can be a wonderful, playful way to answer those why questions. But okay, that's my that's my take on why it's just a good time. But there has been decades of research on how robotics can be used to foster mathematical skills, language skills, visual memory, engage kids in collaboration and teamwork, and engage girls and other underrepresented groups in STEM from an early age through playful and fun and engaging activities. So we know, and I think we think offhand, great, robotics, we're going to foster a lot of technical STEM skills. And that is true. Through a variety of different, depending what the kit offers, robotics can teach building and engineering, the design process. I'm going to be showing you all programmable robotics kits. So they're robots that kids are coding and programming. So they're engaging in computational thinking and debugging. And like I said, understanding the human-made world around them. But robotics can also foster these foundational early childhood skills that we already care about and that we're already working on. Sequencing, that's a really important computational thinking skill, but it's also a pre-math and pre-literacy skill to understand that order matters and to be able to think about things in a logical order. General problem solving skills, fine motor skills as they're building and manipulating with their robotics kits, perseverance. We like to talk about things like coding and robotics as hard fun at my research group. And what we mean by that is learning to play a song on the radio, that's easy fun, right? But learning to play that same song on a piano is hard fun. It takes a lot of hard work and perseverance, but there's a very big payoff at the end. The same can be said for coding and robotics. Just playing with a toy can be easy fun, but building an interactive toy and coding it yourself, that's hard fun. It takes a lot of perseverance, and that is a big life skill that is applicable across domains, not just in the STEM fields. So we know that robotics can be used to foster a lot of traditional early childhood content and skills that we want young children learning anyway. So we can think of robotics as not taking time out of the curriculum where we would normally be focusing on math, or we might normally be focusing on teamwork, that it could be used to foster these same skills that we want our kids learning. So you might be wondering, what are your options if you're working with a preschooler or a kindergartner? What are your best options for choosing robots? Around a decade ago, when I was just getting into this work in the field of ed tech, and I was working on the design of some innovative new robotics and coding platforms for young children, there weren't a lot of options. Most of the things that were out there were for upper elementary, middle school, and beyond. There were a lot of great Lego kits for kids starting in around third grade, but there wasn't a big conversation around coding and engineering for our youngest learners. And I'm so happy to have been a part of this field and watching it evolve over the years. And I'm so happy that when people ask me now, what are my options for early childhood robots, I can tell them there's tons of choices. There are choices for almost every budget as well. And I'm going to be sharing with you some of my favorite options, and I will be sharing with you robots that range in price and range in function in the functions that they can carry out. And then I'm happy to answer any logistical questions that you might have during the Q&A that I will do my best to save time for at the end of this talk. So I'll be showing with you B-Bots, Codapillar, KinderBot, that's another one from Fisher-Price that I think that's like a secret one. Not that many people have heard of that one. And I will be also sharing with you Kibo, which is the robotics kit that is now commercially available through KinderLab Robotics, but it's one that I worked on at Tufts University, and we did a decade basically of research on the design and implementation of that kit. So I'm also going to try to show you the kits in order from youngest learners to oldest learners. And keep in mind, this talk is specifically on early childhood, pre-K through second grade. So I'm not going to get into kits that you might use with upper elementary and beyond, but I will share with you in the chat after this presentation a link to a folder where I will be putting resources. And one of the resources that I already have in there is a little handout on kits beyond early childhood and things like programming languages and kits you might want to try beyond second grade. I can answer a few questions during the Q&A too, if anyone's looking at, well, what do we do after second grade? But I want to start with our youngest learners, our preschoolers. What are our options for a developmentally appropriate robot for them? And what will they even be learning with it, right? So one of my favorite ones is Codapillar. This is one that I have used in a classroom and makerspace setting, and I also use at home with my own kids. And there's actually a few different versions of Codapillar out now. The classic one that most people have heard of is this top image that you see here. The segments of the caterpillar's body is actually the programming language, or the way that we construct our code. And a little kid-friendly definition of code or a program is just a list of instructions that tells your technology what to do. And in this case, it's a list of instructions that are going to tell our Codapillar robot what to do. And so that code or that program is made up of the caterpillar's body itself. So kids are engaging in a little bit of fine motor exploration, clicking the pieces together. They're doing a little bit of cause and effect, figuring out what the different arrows mean, how it works, what do we do when we press the button. And you connect your segments together, you press your button, and you send your robot on its way. And so it's easy as that, but it's programming and it's also problem solving. There's another version of Codapillar if you're working with even younger kids, and I actually started using this with my own son when he was around 2, where the segments are already connected. That's the bottom image here. And instead of each segment having a different arrow on them, each segment has all of the instructions, and you twist to select the instruction that you want to give. I have it here. I can try to demo some of these during the Q&A. So you can actually just twist to select the instruction you want. So if you have a really young learner who that clicking together might be a bit of a fine motor challenge, but they're still interested in some of that cause and effect and just that fun of seeing the robot light up and go on its way, the robot that's pre-connected is even easier, and it's actually a little bit cheaper as well. I'll share some of what I think are the key features or key aspects of these different robotics kits as well as we move along. And I think one of the things that people love about Codapillar is its light up segments, its motorized head. And what kids tell me is they love that the eyes actually light up, and it really brings to life their code. So what kind of curricular activity can you do with Codapillar or any robot? I'm going to show you some activity ideas specific to each robot that I'm showing you, but actually any of these activity ideas can be used with any programmable floor robot that you have or that you're interested in using. So of course, early childhood, most of us are reading a little bit of Eric Carle. The Very Hungry Caterpillar is a favorite book at our house. This is actually my son and something we did with Codapillar, but I've also done in a preschool setting as well. And we connected the arts and literacy and reading to bring the book to life with our Codapillar. And so we created a butterfly that we painted, we counted and sorted the different food items that the caterpillar eats throughout that storybook, and we set it all up on the floor, and we coded the Codapillar's path to move along each of these food items and then stop at the end at the point of the story where the caterpillar turns into the butterfly. So this is something I've actually done with a few different robotics kits as well, but of course it just lends itself well to the Codapillar because it already looks like a caterpillar. And you can do things like this with any storybook that you like and use the robots as a way to really animate and bring that story to life. So instead of just painting a picture or making a diorama or whatever else you would do as a culminating unit on that topic or that book, adding in the robot can really add a bit of hands-on fun to that as well.
Amanda, can I interrupt you just for a moment? If possible, can you share the price range of some of these items that you're mentioning, if you know that?
Yes, absolutely. So you can Caterpillar, there's a few different versions and it ranges, I would say between, this is a rough range, 30 and 80. I got the Code and Twist Caterpillar, the one where the segments are connected, for around 50. And at the end of my presentation, like I said, I'm going to share you the links to these slides. I have links to where you can buy all of these robots. So I have like the Amazon links or their specific web links. So you will be able to click there and find out right away the cost for them. But this one is around that $50 range. I will, yes, that's a great tip. Let me share that as we go along. KinderBot is also in around that same $50-ish range. So it's in the under 100 category. That tends to be sometimes how people think about purchasing technology for their classrooms or home use. It's also made by Fisher-Price. And this was one that I actually came across as a parent. I've never used this in a school setting, but I was looking for more of like cost-effective programmable robots that kids could use starting at that preschool age range. They say around ages 3 to 6, and I think that that's about right. What's interesting about KinderBot is, well, a few different things, right? For kids who are already obsessed with robots, it looks like what they think a robot quote should look like. And I will be introducing a kit later on that breaks that notion of what robots should look like. But for kids who like WALL-E, I know that's a throwback movie, but some parents have still been watching that with their kindergarten age kids. This one has this friendly appearance and it's still around the price range similar to Caterpillar. And it has 3 different ways to play. There's a free coding mode, which you can give the robot instructions however you want, just like with Caterpillar. Or there's a challenge mode. So it will challenge you to do things like create a code with exactly 3 instructions, or create a code with a forward and a backward. So there is this built-in learning challenge mode, which I think is helpful if it's a parent or teacher who wants something that's more hands-off for them, that's less for them to build the curriculum, but something that would be fun and challenge kids without them having to do a lot of planning. And it also comes with this secret code book, which I'll show you about a little bit later too, where if you type in a certain sequence of codes, you can get the robot to do different kinds of fun things. So you're learning very similar things that you would with Caterpillar in terms of sequencing and problem solving, but they've also included some things to help foster an exploration of shapes and colors and counting through that code book and through those learning challenges. And you can also see here, KinderBot is holding like a triangle thing and a circle. So it comes with a little bit of things that you can play with building and assembly, whereas Caterpillar, really it wasn't so much, it was mostly about the coding. Yes, you're connecting the segments, but mostly you're not worrying about actually engineering. It's very focused on just coding. KinderBot has some prompts where you can explore with simple machines or making little obstacles with these little add-ons. So you can, this is a top view so you can see. So the way, the programming language or the way that we're communicating and giving instructions to this robot is through those directional keys on top of the KinderBot's head. And that's just a little close-up of the secret code book. So one activity idea with KinderBot is if you want to incorporate an exploration of shapes, there's already this series of instructions for that in the code book. You can type in the codes exactly as they are in the code book, and KinderBot will act out, will draw essentially these shapes on the floor. It'll move in the floor in these shapes. And I'm avoiding showing video content during this presentation because that can be a dangerous game on Zoom with many attendees. But this robot has a really lively voice. It says things like great coding, and it does like music and lots of things when you solve the challenges. So it's really a fun robot that kids really, I think, appeal to it. They even call it like a robot friend in some of their descriptions of it online, and I think it definitely falls into that category. So then moving on to BBot, this one is also, I think I've just accidentally put them progressively by price too. BBot, I don't know the exact price of BBot, but it's slightly more expensive than the Caterpillar and KinderBot robots that I just showed you. And this is also preschool-ish level. They say 3 and up. They don't give a specific age range. I've seen some teachers use this up through 3rd grade, but I have mostly used it in that K through 1st grade-ish setting. And BBot is programmed pretty much exactly the same way as you just saw KinderBot being programmed. It also has directional keys on top of the robot. So you're also learning the same kind of programming, sequencing, problem solving, all of that. But one of the things that people really like about BBot are these activity mats. And so it allows you to integrate with a variety of different subjects through the use of these mats. So they sell them online. The mats can be pricey. The bundles are in the hundreds, but you can also make your own. Something that I've noticed with teaching with BBot, as well as some of the other robots, is BBot has really precise movements. It will turn really exactly 90 degrees and move the exact same amount. So it's perfect for work on these grids or these mats, whereas some of the other robots, it's not as precise of movements. Because it makes these really precise movements, because there's all these mats that you can buy for BBot or that you can make yourself, you can really integrate BBot with any subject that you want. You can see some examples on here through navigating through your community or exploring sight words or letters, math or counting. You can integrate your coding that you're doing with BBot into any subject that you're interested in. So then I want to move into the Kibo robot. Kibo is a bit more expensive. This is in the hundreds category. They have a few different versions though. So there's a starter kit that has just basic motors and outputs, doesn't have all of the sensors and art platforms. That's the cheapest one. And then getting higher into the hundreds, you get kits that have all of the different bells and whistles that I will show you about. They had a rental program happening during COVID where you could rent kits for a certain number of months and they're sanitized in between. They also have some resources on their website for writing grants and fundraising for Kibo. So while it is very pricey, and although Kibo is a robot that I'm very passionate about, that I worked on the development of for many years, I recognize that this is not the most cost-effective robot for a lot of people. And so I always like to show that spectrum of options, from something you can get for like $50 to something that you're investing in that the cost is going to be in the hundreds per kit. But let me tell you a little bit about how we went about creating Kibo. It's based on over 15 years of academic research at Tufts University and beyond. What we involved teachers, parents, and children in every stage of the development and research of this robot. It actually started out as a hybrid robot where you could connect it to a computer. And what we found, our feedback from preschool and kindergarten teachers, was that was just a burden and unnecessary, that they wanted more tools that are completely unplugged. So we got rid of that, and it is a completely unplugged kit now. I organized the robots accidentally by price, but also a little bit by age range, because this is a slightly older age range, around the ages of 4 to 7, even 8-year-olds and slightly older. They've been putting out some newer materials and blocks that slightly older kids can do things that are more complex. So I definitely not a 2 or 3-year-old, although I have done it. That would be more of a fun cause and effect type of exploration with Kibo. For actually learning some of the concepts that I'll be sharing, this is more a 4 to 7 age range recommended. And just like BBot was designed to integrate across, all these different curricular domains with their mats, Kibo is also designed for open-ended play, as well as the ability to integrate across different school curriculum. And I mentioned that I'm not going to risk playing any videos during this talk, but if you do visit my slides after this presentation, this is a quick 4-minute video that I created that shows Kibo in practice with kids and teachers and what you can do with it, how it works, and also gets into the background of how we developed and iterated on this kit as well. Oops, as I said that, it wanted to play. Okay, so without playing the video, I can show you this picture that shows you the spectrum of what we did with designing Kibo, not just playing around with the colors to make sure it would be equally appealing to kids of all genders and backgrounds, but also the parts and how they would look and how they would feel, and trying to really create that wooden, traditional, manipulative feeling that we like in our early childhood materials. So Kibo has all these really easy to snap together parts and modules. So there is a little bit more of a building component as opposed to some of the other kits that I showed you. You're actually assembling Kibo. You need to connect wheels and motors for it to work. And another key feature about Kibo is that many of the parts, as possible, are transparent. And that's because a lot of kids find technology to be a mystery and to be working by magic. And we wanted to kind of disrupt that mysterious black box and actually show kids what's going on inside and let them ask questions about it. And BBot actually has a transparent version as well that you can look up, where you can see all the inner workings. Kibo has where the bottom of the robot as well, you can look inside and see how everything works and ask questions about that. So there is this engineering component where you're actually putting together the motors and the outputs and the sensors, which is not part of what you do with the other robots. And you're also doing your coding. So in the case of Kibo, the language is a tangible wooden block language. So kids can build their code in front of them and see it, and they can actually use their hands as they're problem solving and trying to figure out what went wrong with their code, why isn't it working the way they want it to work. And the robot has a scanner, and you just scan the barcode on each block, and then that sends the program to your robot and it acts it out right there. So there's all sorts of different key features and add-ons, sensors, outputs. My favorite newest part is a sound recorder. So you can actually record your own sounds and then program that into what the robot does. There's art platforms and more. And the other key feature, although this is a positive or a negative depending on what your goals are with choosing a robot, is that it has this just generally neutral appearance, right? So BBot is this lovely bee. We have this caterpillar robot with big eyes. We looked at KinderBot, which had that face that really reminds me of the WALL-E robot, if anyone has seen that movie. But Kibo doesn't look like anything. So at first bat, this might be a negative to some people, but to me, it's a positive, and it was actually done on purpose. And we wanted to create a kit that would be more resemblant of a blank canvas and paint than something specific. We wanted to create something that didn't look like anything until kids put their own imagination on it. And we want kids to build with arts and crafts and materials and create their own Kibo and have it look and feel differently every single time that they use it. So this is just a close-up appearance of Kibo's programming language. So with Caterpillar and KinderBot, with those robots that are designed for really young users, there's not really any syntax rules, right? There's no way you can accidentally do something that isn't going to work, right? With Kibo, there are a few basic rules, like you need to start with a begin and end with an end. And as you do more complex concepts, there are a few more rules that you need to learn. And this allows you to liken it to language, right? In the English language, we start with a capital letter and we end with a punctuation mark. And people might be confused if you forget that punctuation mark. They might not know exactly what you're trying to say. And we can use this as a parallel when talking to kids about code, that we need to follow these syntax rules so that the robot knows what to do. Otherwise, it's going to be confused and it's not going to do what you think. So there is more opportunities for debugging, but there's also more complexity for the kids and as well as the teachers or the parents who are using a tool like this. So I'm not going to play this video, but if you do check out my slides afterwards, you can see how kids dance along to one of my favorite activities with Kibo, the robot Hokey-Pokey. And so this is actually something you could do with any robot that you could program to move on the floor. And I like to integrate songs and music because it gets kids doing something physical. They're not just like hunched at their desk with a robot. But it also, and it integrates music and gets a lot of kids excited and interested. So of course you could program your robot to do any dance that you want, but using a song like the Hokey-Pokey or maybe the Cha-Cha Slide or other songs that have specific actions will force kids to do problem solving and debugging. Because if they're just making a dance to any song, they can change their mind afterwards and say, oh yeah, I wanted my robot to do that. And that's fun and that's fine for free play. But if you really want to get kids into this debugging and problem solving, giving them something with a very specific sequence that they can work towards is really helpful. And the other thing I love about this is that even though all the kids would be working towards the same end goal, having their robot do the Hokey-Pokey, so having their robot go in and then out and then in and then shaking and spinning and turning themselves about, there's still multiple right solutions. And that is the beautiful thing about coding. Kids often get it in their head, and adults too, that there's one right way to achieve a goal. But that's not true in engineering and coding. There's always multiple ways to achieve the same outcome. So even in something like the Hokey-Pokey with the block language that Kibo offers, there's multiple ways you can get your robot to do this. So for example, Kibo has a spin block, and that's often the block that people will use for this turn yourself about lyric, but it also has left and right turns. So a kid could do a few left turns or a few right turns to achieve that same turn yourself about look. So I think activities like this are really great. And regardless of what robot or what activity you're doing with your kids in class, talking about that idea that there's multiple right ways to achieve the same goal and having kids share out their different solutions, I think is so valuable. Oops, it wants to play it even though I wasn't intending to. So I hope this isn't freezing for everyone.
No, we can see it. It's very cute.
Okay. That was with, you might have noticed that Kibo looked a little bit different. That was one of the earliest prototypes that we had, and that was at a school in East Boston that I was working with. So here are some more curricular activities you could do with Kibo or with any robot, but this is really just showcasing that with a tool like Kibo, as well as tools that you can use for slightly older kids, like the Lego robotics kits are also ones where there's one way you can build it, but you can also build them to look totally different if you want to. Kibo wanted to do that, but for young kids, right? So you can make Kibo look differently every time you use it. And that way it can really integrate into anything that you're exploring. So snowplow, not so relevant here in Hawaii, although for our kids here, snow does hold a certain fascination because we don't get to see it. So it still can be fun to do a unit that has to do with plowing snow. My community, similar to what I shared with BBot, you can have kids create a map and represent their neighborhoods, and even just fun things like bowling and whatnot you can do with your robots. Whatever it is that you're doing, remember to make it fun for young children. So teaching through games and music and the design process is something that's really important to show that we're iterating and that it's okay that you're not going to get it right the first time, that we always have more questions to ask. And so creating design journals or handouts can be really helpful because that planning phase is something that young kids tend to want to skip a lot, but it can be really useful. So there are some factors to consider, age and developmental considerations. Do you want something that's completely screen-free or something that has digital components like Dash or Dot and those robots by Wonder Workshop? I didn't show those today because I specifically wanted to show you screen-free robots, but you might want something that has a digital integration. And then the big question with the robots that I showed you today is, what do you want kids learning? If you just want them to do coding, you don't necessarily need something where you're building with motors and outputs and sensors. But if you want them doing building and engineering, then you need to to think more about one of those more expensive kits that can do a little bit more. And then, of course, like we talked about, budget is, of course, a real consideration. With almost all of these robots, it's pretty easy to have kids work in partners or groups when we're not in the time of COVID. I know that that's not always possible right now. We have kids really separated and not sharing materials, but in a normal environment, most of these, you can think about having multiple kids share on one robot or doing something with centers. So just a couple of final tips. I do want to save at least 5 minutes for the Q&A. Some of these kits can be overwhelming to you, so make sure you're trying it all yourself, but don't worry that you might also make mistakes in front of the kids. In fact, you should celebrate it and call it out because you're a role model and you want to show them that it's okay to make mistakes and it's okay if you don't know the answer, but that we can work together and find out the solution. And celebrating the process over the final products. If you need a classroom management tip, I think this ask 3 friends rule before you ask the teacher is really great because it shows them that their peers can help them, their peers can become experts, and it also takes a little bit of pressure off of you if they need to ask 3 friends before they ask you, but it also fosters collaboration and teamwork. And the other thing I just wanted to point out is, of course, we were talking a little bit about learning to code, but all of the curricular activities that I shared with you are coding to learn. So it's not just learning to code, but it's using coding and using robotics to learn and explore other topics or other domains. And that's really where the power of coding and engineering can come into play. So I'll paste this link into the chat after when we move into the Q&A, so you have it, but you can find the links to these slides in case you wanted to watch all of these videos or you want to find some of the other resources that I have for you, like handouts. I have a handout of the engineering design process that might be useful for you and things like that. And here, like I promised, is links to all of the robots. So if you wanted to actually go in and do some exploring, most of these, there are multiple versions that kind of range a little bit in price. You can definitely grab my slides and find all of these links for yourself. And these are just a few books that you can find that might be helpful as well. And if you're looking for more training opportunities that can be done remotely, I have a little handout about this Early Childhood Technology Graduate Certificate Program in that folder as well. But now I am going to stop talking so that we have about 5 or 7 minutes to do some Q&A and some discussion. Thank you so much for tuning in, and I'm really looking forward to see what thoughts or ideas or questions that you have. So let me turn it back over to Caitlin now.
Thank you so much, Amanda. I really like what you said at the very end there, where it's not just about learning to code, but it's coding to learn, and what can we do with coding and with robotics eventually, that really where the power lies. We do have one question already, and I'll share that in just a moment, but I do want to say to everyone, you have 2 options. You can either go ahead and put your question into the chat and I can voice that for you, or if you're comfortable, you can unmute yourself and go ahead and ask that. So Miriam is interested in knowing, what do you recommend for students that are fully distance learners?
For students who are fully distance learners and you can't give them like material kits to send home, which I know some schools have been doing rotating kits that they send home to kids to use. So if that's not a possibility either, unfortunately, I don't think any of these are the best for that. I think maybe my next presentation on Scratch Junior will be very useful to you. That's a digital app for young children ages 5 to 7. Okay, that being said, if you already have one of these robotics kits, I have sort of worked with some teachers who have done like Zoom presentations, doing demos of Kibo, having kids suggest what blocks, and they have like a camera set up so that kids can watch what the teacher's doing with their robot. So something like that you could do with any of these robots. And the way a lot of these teachers are framing it is they're teaching the parts of the robots, they're teaching the syntax rules, they're teaching the commands, and they're doing some fun things together as a class on Zoom. And they're hopefully setting the stage so that when kids do come back to school in person, they can move on to something more complicated, more of that code to learn rather than learn to code, and they can do more complicated curriculum because they already got the basics through a virtual setting. Some unplugged games you can do through Zoom, Program Your Teacher, Coder Says, things like that. But if you really want them using a technology and you can't provide kits to them, then you might want to consider doing like a digital app instead. That's a great question.
Thank you, Miriam. That is a great question. And we do have a few more minutes if anybody else would like to ask or make a comment.
Just sharing my contact info in the chat, as well as that folder I mentioned, in case you want to get the slides or anything like that.
Great, that's wonderful, thank you. Okay, so thank you, Amanda. That was really a wonderful, thought-provoking and inspiring presentation. And thank you to all of those who attended for your participation. We hope that you will find this session helpful and make some valuable connections to your own work with your students. Please help us complete the survey on the iTeach 808 website, and I'm putting the link to that into the chat right now. And then the survey will be sent to the email address that you registered with, and please check your spam folder to make sure that you get any and all emails from iteach808hawaii@gmail.com. And with that, you may go ahead and exit the session. And thank you again, Amanda. And thank you to Mira as well.